Hello, everyone. Welcome. Thank you so much for joining us today. While we let everyone trickle in, I'll go over a quick introduction here and I'll pass it over to Mindy. So we have Mindy here from TRA Snow and Sun, and my name's Kayla. I'm here representing the Acelab team. So I'm going to take you over to Acelab real quick to show you TRA Snow and Sun's page. So here we go. All right, so in just a moment, you should be able to see my screen. So here on Acelab, if you're not already familiar, a really great place to start when you're doing any specific kind of research, you can use the search bar at the top of the screen and filter for products, manufacturers, resources, or you can use our new AI search. That's another great tool that we have now. So in this case, we'll make sure you toggle over to manufacturers. And here on their page, we've got a lot of great information for you. We've got Mindy's contact information here, front and center as well. And of course, there are products here for you to explore and learn more about. So you can click into any one of these products to get some more information and also save it to your firm library right here for future reference. All right, so definitely check out their page when you have a moment. I'll drop a link in the chat for you all. And a couple other housekeeping items. So today is an AIA-approved presentation. So we already collected your numbers upon registration. If you're worried that we didn't get your number, I will go ahead and put a form in the chat for you. Fill that out, and we'll make sure you get credit for today's session. Also, we will be doing Q&A at the end of the presentation. So if you have any questions throughout, feel free to just go ahead and drop them in that little Q&A button at the bottom of your screen. And we will get to as many as we can at the very end. And you also see a webinar poll pop up on your screen about 3/4 of the way through the presentation. And that there is a great way to get some follow-up information after today's webinar. It is an optional poll, so if you're not interested in getting any kind of email follow-up, just click the X, it'll go away. However, if you want to get connected with Mindy and her team directly through Acelab, fill that out with any specific questions you may have, items that you're looking for, specific project information, and we will connect you via an Acelab conversation. So within a few days after the webinar, you'll get an email notification from Acelab saying that you have a new conversation. You can respond directly to that email or hop into Acelab and respond to any conversations there. So definitely keep an eye out for that after the webinar if you fill out the poll. And we also have a post-webinar survey as well. That's a really great place to leave any feedback or additional follow-up questions you may have. So we appreciate it, any feedback that you may have for us. And with that being said, I will go ahead and pass it over to Mindy to get us started with the presentation.
Of course. Well, thank you, Kayla. My name is Mindy Dahlquist. I am the Business Development Manager at TRA Snow and Sun. And I would say I'm located in sunny Ohio today, but it is pouring rain. So if you can hear that in the background, I do apologize. It is just coming down out there, but it was much needed. So we will take it. But today we are going to focus on rooftop snow retention. And thankfully, we haven't seen any snow yet this year, but that will be coming very shortly to many of us. This course is an AIA-approved presentation. It has been researched, assembled, and produced by TRA Snow and Sun. So if you have any questions or concerns about the content, please just let me know. I'm more than happy to help answer those questions or find that answer for you. Basically, what we're going to discuss today is a review of the problems, safety issues, and solutions that are associated with snow and ice moving on roofs. Particularly, we're going to focus on the heavy snow accumulation areas and also go into some of the engineering and installation of these snow retention systems as well. This course is designed, currently there's a gap that's created by the absence of codes and standards relating to snow retention at all. And so we're just trying to help bridge that gap to help professionals such as yourself be able to answer some of those questions and be able to deal with some of the issues that we are seeing on the rooftop in these snowy regions. At the end of this presentation, you will walk away with a lot of information. These are just some of the things that you will be able to discover throughout this presentation. But I'm just going to start us off real quick here with a video. I don't know that my sound is actually going to come across for you, but I'm going to go ahead and play the video one way or another.
Second is how long it took for snow To fall off the roof, the toddler and two 7-year-olds were buried in that snow. It takes more than just a row of snow guards placed haphazardly on a roof to prevent tragedies such as these. Using factors unique to each building, including snow load, slope of roof, type of roofing product, sheathing type and thickness, and attachment type, will help you to create architectural masterpieces that are safe and reliable for years to come.
So with that video, you can see that we are talking about heavy snow. So this is going to be the most dramatic side of this. This is in Lake Tahoe, California. And so the snow loads there can range up into 465 pounds per square foot. I'm on the opposite end of that spectrum. I moved back to my home state of Ohio. I believe my snow load is about 26 pounds per square foot. But don't ever let those numbers fool you, because last year I live in a brand new house with a metal roof on it. And last year my gutters were actually torn off on the corner of my garage due to the ice that slid off on the corner of the garage. So just because these massive snow loads come with these large numbers does not mean that we don't see damage in the lower snow load areas as well. But for this presentation, we're really going to focus on these mountain regions and these heavy snow accumulation areas. So we're not looking at a light and fluffy little bit of snow. This isn't snowball weather or snow angel weather. This is massive amounts of snow. When the snow accumulates on the roof, it glaciates. So what you're dealing with is not just a couple little piles of snow up there that you can take a broom and just hit them down. And the goal of snow retention is not to break that snow up as it slides or any of those types of things. That since that snow is a glaciated mass, the snow fences and brackets are utilized to help protect that snow from ever being able to slide off of that roof surface. Because what we're seeing in this photo here is a dormer that's been torn completely off of the roof. And I always look at this and say, you know, if this is something you pull up to after work and this is your house, I think you sit there for a minute and look at it and then you just keep driving, because where do you even start? The snow is heavy and hard. It's going to be very hard and difficult to deal with. Basically, the slide just says it's going to get heavy and hard, does not stay light and fluffy, as I just mentioned. Since there are no codes or standards that relate to the engineering, manufacturing, or installation of snow retention systems in both the US and Canada, the building codes at this time are pretty much silent. This does result in at least the following that we are aware of at this time. Due to the lack of codes and standards, snow retention companies can manufacture their systems however they want and out of whatever materials they want. So I have just a coffee cup sitting here, a paper, cardboard, whatever it is, coffee cup. And if I wanted to take this and sell it to you and say, if you super glue this to your roof, all over the whole entire roof, this is a snow retention device. At this time, there is no standard to say that that device will not hold snow back. So it's really important to make sure that you are dealing with the correct manufacturers who test their products and all of that to make sure that that product is actually going to be substantial enough to keep the snow back and to remain safe on your roof. Municipalities also have a difficult time codifying snow retention since there's no standard for them to reference. So oftentimes in areas such as Lake Tahoe, California, and places like Truckee, it's very difficult for them to say, hey, you need snow retention on your roof. Well, does that mean 6 brackets above a doorway? Does that mean 1 fence? How many pipe does that fence need to go up? There's a lot of different situations that are going to happen, and snow retention is not a one size fits all application. So with that, municipalities kind of just are hands off at this time. Owners also don't want to pay for it, even if it's needed, because it's not required by the code. And then architects have a difficult time knowing exactly how to specify that snow retention system and where the placement of that should be, how much weight it can hold back, all of those good things. So what are some of the common hazards and challenges that are caused when snow does move on the roof? So you have personal injury and death, which is going to be the most serious situation. Damage from sliding snow and ice, Premature aging, I actually had an architect ask me one time if premature aging was for the roofing material or for the homeowner. And now I always have to include that it really could be for both. The premature aging occurs on the roof surface, but if you've ever had to replace your roof early, you know that that causes a couple extra gray hairs in the process. Limited and restricted access and views, and then ground snow removal. So normally I would play one of these videos. I'm going to just go ahead and skip the videos just because I'm not sure if that sound is coming across. But these are all news clips from different states in the United States on situations where there has been a death or multiple deaths that have occurred from snow sliding on the roof. Instead, I'll just kind of take this time to talk to you about my own experiences with this and some of the involvement that we've had when these situations do occur. Just last year, there was a 5-year-old girl in Durango, Colorado, and a 50-year-old man in Utah within the same week. Both passed away from rooftop snow avalanches, and one of them was at Purgatory Ski Resort. And so these things happen over and over again. They are oftentimes, or every time that I've seen it, called a freak accident when it does occur. But if it's something that's happening over and over again, and I have 3 news clips of videos of 3 different deaths, it actually was 4 different deaths in 3 different areas. But when these things are happening that often, it's no longer a freak accident. It's something that is a concern and does need to be addressed as we plan and build these structures. We need to keep in mind that the snow does sit on them. So on to a much less serious side of things, the damage to the roofs that can occur when the snow does come off of the roof. As you can see, there's just a little bit of damage on this metal roof on the dormer there. Any design factors such as this double valley that we're seeing here will also increase the amount of damage that can be seen, because now you are funneling that snow and funneling that weight and forcing it into these smaller areas to try to have it come off of the roof. And so you have multiple different slopes going into that. And with that, you can see damage as we're seeing there. Those were also metal shingles. So they basically just end up crumpled up like they were tinfoil. Penetrations are also a very easy target to sliding snow and ice. The PVC pipe that we're seeing on the bottom there, that oftentimes we actually see sheared right off. I believe they're missing a fastener on that. But even the metal pipe that's utilized for electrical wiring conduit and penetrations can give way to heavy snow and ice. It is just pouring here. So when the snow sheds from an upper roof to a lower roof, it most definitely is damage. It's a little hard to see in this photo. This is a Utah example. We manufacture out of Utah, so we get a lot of photos from there. But as you can see, this big old dent in there is just not supposed to be there. And as you get down towards the eave of the roof, there's a really nice squiggly pattern that is not supposed to occur on your roof surface as well. And just like any other surface, when snow and ice freezes to that roof surface and then moves, it can damage it by taking part of that roof with it, as we're seeing here in the valley and the rake of this roof. This is a standing seam metal panel. The most interesting fact about this project here is that this panel was pulled off as the snow slid down, but it comes off so quickly that it did not even bend that panel. So as we know, these panels are pretty flexible on their own, even with the backing on there. And so with that, it's just showing how fast that snow and ice is sliding off of the roof surface. Another roofing challenge associated with snow and ice damage is damage to other parts of the structure besides the roof. So oftentimes the phone calls that we receive will be something like, the snow came off my roof and hit my neighbor's solar panels and busted those, or it came off of my roof and took out my fence or my neighbor's fence or my car or my neighbor's car, all of those fun things. And there are other people involved. So if you have neighbors involved or you've crushed somebody else's, that's always the customer in the end there. But something that's, I'm very sarcastic, so it always comes across in my presentation. And it's telling me my internet is unstable, so I hope this is still coming across well for you. But as you can see here, there are two cabins side by side. One does have snow retention and one does not. One also still has their deck enclosure over there, and one does not. Obviously, this can be a level of protection to just make sure that the structure is still in place. This photo just shows the dangers of gas meters being damaged and torn off the building. This can result in possible explosions. Oftentimes, codes and standards now do cover the gas meters and of snow shed areas, but it's just another thing to consider. Sometimes the roof does not have a steep enough slope to shed that snow quickly, so snow sliding off of the roof surface can curl under the eave and damage other parts of the house, such as windows, doors, those types of things. Now, I call this creep and curl. That's not a scientific term, but what is the majority of your heat loss is going to occur up at your roof's uppermost peak. So up at the ridge of your roof is where you're going to have the majority of your heat loss that happens. Heat rises, as we all know. And as that heat begins to escape from the peak of your roof, the snow will begin to melt and slide down that roof surface. Well, as it reaches the eave portion or the lowermost part of the roof, that is going to be much, much colder. There's a lot more airflow that's occurring, and so it is just a colder part of the roof surface. So with that, you not only have the start of ice damming and that creation with that temperature difference, but you also have gravity coming into play. So as that snow and ice has slid off the eave, it's sitting there, it begins to curl underneath and begins to come down. It does result in broken windows oftentimes, and usually there's nobody home to see that these windows are being broken this way. So sometimes it results in a phone call to the police as well until you realize that you have not been actually broken into and it is just your roof coming after you instead. Property adjacent to the structure can also be damaged from sliding snow coming off of the roof. The photo on the left, this is in New York City, and the photo on the right, I believe, is in Montana. But these photos just show that the snow can come off and hit vehicles. And I know the man in the left with that Equinox, he was not in the car at that moment, and it was a multi-story building. The ice came off in chunks. I'm sure he was very thankful he was not in there, but probably not so much fun dealing with insurance and all of things with his vehicle. Photo on the right, PVC pipe is something that we see on the roof very often as an attempt of snow retention. PVC pipe should never be holding back weight in that form. And unfortunately, these people who were visiting this motel also had the joy of cleaning out the snow from their car and their windshield and all of the other things. So it definitely is something that should not be patched together. It should be installed and engineered as a system with thoughts and planning, and you are holding back thousands of pounds of weight at many times. So the force of the snow mass on this photo, it just shows how much that snow wants to stay in one massive piece once it has glaciated. This light pole is never intended to be a snow retention device, but here it is doing a pretty good job at it. Premature roof aging. So here's those gray hairs that I was talking about. Snow and ice can cause that roof to age prematurely, whether it is your asphalt shingles or a metal roof surface or any of the other types of surface. You have a lot of freeze thaw cycles that are occurring on the roof surface, and then you add the sliding of that ice and snow. Just as the shingles, it can take off those granules on metal roofs. It can take off the protective coating, the paints, all of those things as well. Limited restricted access and views. So as you're entering these buildings and homes, those entrances can be blocked by snow and ice that falls from the roof, such as what we're seeing right here in this cabin. And we have to understand that the snow is heavy and hard as concrete. It is not something that you're going to get out there with a cute little plastic shovel and shovel away from your doorway. I did heavy snow removal in Utah, and any of those snow piles that sit for any period of time, the moisture concentration changes in them and they just become solid ice. Many homes and cabins are, and also commercial structures are built with snow shed in mind. When that is happening, you do have to take a lot of precaution on where that snow is going to go. So this cabin was built with snow shed in mind. They're allowing that snow to come off of the roof surface, but the biggest problem is the entrances to this cabin. So the parking is down on the far left of the photo, and there's a beautiful walkway that takes you to the main entrance that is on the right behind that pine tree over there. So hopefully they have a nice little snowmobile to get them and their groceries to that front door, because otherwise that's going to be quite a task. So this home, obviously they knew that they had concerns with snow shedding. They have crickets installed on all of their penetrations on the roof surface, but they still were ending up with broken windows year after year. So they decided to do a DIY, do-it-yourself kind of solution for it, which I totally understand, and installed some plywood sliding barn style window coverings. Unfortunately, it just didn't work out so well for them. They still ended up with two broken windows, two broken window coverings, and now you're just preventing any type of daylight to the outside as well. I don't know about you guys, but I need the sunlight coming in my house or I will go a little bit crazy. So once that snow does slide off of the roof, oftentimes it does need to be removed. So removing ground snow, this is something that can be costly, time consuming, and labor intensive. So this is actually my husband and my daughter in that loader there, and it is something that is very, very costly. The company that I worked for in Utah charged about $350 per hour per piece of equipment to run heavy equipment and remove snow. That's not including any salt or ice melt, any materials put down at all. That is just solely moving that snow around. So understanding that if you're building commercial properties or residential properties, understanding that cost and the longevity of that cost as well is very important. So what are some of the everyday solutions and possibly the disadvantages to those solutions? There's the sign approach, the caution tape approach, and manual rooftop snow removal. So the sign approach, this is something that I see all over in mountain towns. Some choose to simply put up a sign that says danger, falling snow and ice from roof, walk well or park clear, something similar to this. Unfortunately, when it comes to litigation and it comes to some type of lawsuit, you are never going to win in this situation. It's going to say, listen, I knew there was a big problem and I chose to put up a sign that was the same color as my siding and was going to be covered with the snow as soon as it started to snow. It will not remove any type of liability from the property owner, and it will not stop damage or injury. And oftentimes these signs are put in very interesting places. So nothing says handicap accessibility more than here's your handicap spot, but just make sure that snow doesn't fall on your head. And something that's very important that I'm seeing more and more, even with the conversations of the death of the 5-year-old girl in purgatory, is when these come to an issue or a lawsuit, they go after everyone. So the insurance company or whoever is going to go after the architect. They're going to go after the roofer. They're going to go and see any person that they find might be responsible for avoiding the snow retention. So as a manufacturer representative, something that I always recommend to my architects, to my contractors, is just cover yourself. Even if the owner or whoever is not wanting to do snow retention, if you think it's something that's necessary, always have them sign something off. Or if you're recommending to follow manufacturer specs, on the snow retention and they decide that they're going to go off on their own and just put some bars over here and some clamps over here, just cover yourself and make sure that you have them sign off on the liability of that. That does help yourself in the long run to help save you some stress. So the caution tape approach, some do choose to tape off or orange cone off areas where the snow does shed, as you can see in this photo. That has many flaws to it, whether it can be moved, the tape can be broken, the snow falls on the tape, someone's kid is using it as a jump rope. You never truly know, but it's something that just does not work out so well. Manual snow and ice removal. I am going to just try to skip this video because I think this one usually pauses my presentation when I display with Acelab. So I'm just going to skip it to be safe. Some do choose to shovel the roof off each year, risking damage to that roof surface and endangering those shoveling below. It does result in costly labor expenses. It's very dangerous. OSHA puts out statements every single year about the risks of shoveling snow on the roof surface, which of course makes sense since roofing can be quite dangerous as it is, and you throw snow and ice up there, it's just maximizing the danger completely. This also puts the roof surface at risk because you have gentlemen up there who have metal shovels, oftentimes pickaxes to be able to get through that snow, some spikes on their boots for their own safety. And so it's just very, very important to understand the risks of having someone up there shoveling that snow off as well. And as we all know, we've all seen fail videos on whether it's Facebook or TikTok, whatever you utilize. I'm sure you've seen videos of people sliding off of the roof, coming down with that snow pile or trying to hit it with something and the snow comes down with them, those types of things. The video on the left, I normally show, it's in a different country. I'm going to just bypass it today, but this gentleman just slides right off that roof very quickly. It's a 3-story building. He gets up and walks away, but still not a good day for him. The man in the middle, I'm not exactly sure what his end game will be there. I don't believe that gravity is about to be his best friend when that snow does come away from that other snowpack. And the photo on the right just shows how much manpower it takes to be able to handle this type of snow on the roof and how much effort it is going to be to get that off of there. So what type of design practices can we look at in the US and Canada as potential solutions? So in the US and Canada, as a general rule, we design our structures with steep sloping roofs in the mountainous regions and low sloping roofs in the lowlands. With that steeper roof, it does allow for the snow to slide off more easily, but we kind of design more around the snow itself and not addressing any of those disadvantages that we've just discussed. Where Europe's design strategy is actually the exact opposite of what we do in the US and Canada. They choose to utilize a low slope roof in mountainous regions to prevent damage to the roof surface, as well as retain the snow on the roof as an insulating blanket, helping to promote that energy efficiency and also taking away that risk of injury to residents, guests, property below, all of those types of things. This design strategy does allow for more architectural freedom. It does give you that design freedom, and you also keep that snow on your roof as an insulator. So dormers, whether it was ever intentional or not, dormers actually work very, very well to hold snow in place or divert the snow once it's moving. So they do shield certain areas such as walkways and entrances below the building. But with that, dormers kind of come with their own list of disadvantages. Although they can be effective at diverting the snow, oftentimes that roofing product isn't strong enough or durable enough to handle the weight of that snow and the force of that moving snow into them. So this stormer did a great job of diverting the snow, but unfortunately has a massive amount of damage that will need to be fixed. And Oftentimes, something that's overlooked is when these damages occur in the winter, you may not know that that roof even looks like that underneath the snow surface until the snow melts off. And at that point, you most likely have a leaking problem and other concerns going on that sheathing as well. So another problem with dormers is they create a lot of areas on the roof that are going to alternate regularly between sun and shade. With that, you're increasing your freeze thaw cycles that are happening, and it can cause leaking and damage down the road. So what about slippery roofs, non-slippery roofs? Are there solutions in that? So slippery roofs like your metal, composite, and synthetic, eco roofs, single ply roofs, all of these roofing materials together are going to be very slippery and will not stop that snow from moving on their own. So this is the Dallas, Texas Stadium. This is game day, and this little bit of snow comes down and it slides off of the stadium roof there and it hits 6 people. Those 6 people file a lawsuit and do win. So this does result in a massive lawsuit for the Dallas Cowboys. And they actually, due to this lawsuit, the marketing or the management company, sorry, I've lost my words completely. The management company that manages the Dallas Cowboys also manages the Mercedes-Benz Stadium in Atlanta, Georgia. And so with that, the Atlanta, Georgia Stadium actually has a massive custom snow retention system all the way around it. So if they're planning for those type of events in Atlanta, Georgia, due to something that happened in Dallas, Texas, then we most definitely need to be planning for these types of events in areas where snow is a prominent issue. So other roofs that are not very slippery and snow does not move as easily on them is going to be your tile and slate, wood shingles and shakes, asphalt shingles, and rock-coated metal shingles. So oftentimes it's thought because they're not as slippery that snow just will not move on these roof surface, but that is just not the case. So here is an example of a tile roof surface. Oftentimes it looks like a jackhammer just came in and tore it up when this does occur. And understanding that the snow still freezes to these surfaces, and then once it does move, it can take those products with it and then can also take other things with it as well. So there's a deck railing that's been removed from this house that has a wood roof on it. And then asphalt shingles, most definitely, yes, the snow can move on asphalt shingles. It's oftentimes just going to happen more in the spring when that melting starts to occur. You've got water that's running between the snowpack and the roof surface. The temperatures are varying so much in that early springtime where you have those warm days, but the nighttime is freezing again. And so as that water runs, at night, it refreezes between the snowpack and the roof surface, just giving it the perfect environment to toboggan right off of there. So basically, all roofing types in snowy areas can have a problem associated with moving snow and ice. So moving on to modern snow retention systems and getting away from the why of snow retention and really just focusing on that this is not a new concept. This is something that has been going on for centuries. Oftentimes it was logs, rocks, or boulders that were put up on the roof for that purpose to keep for the snow from sliding off. Now we've moved into more modern devices. So at this time, your more modern devices are going to be something like a snow bracket. Snow brackets are going to lie directly on the roof surface. Generally, they will cover the entirety of the roof, mounting to the sheathing, the battens, or the roofing product itself. Where snow fences will act a little bit differently. Snow fences will clamp onto that roof standing seam for a standing seam panel, or they will have a deck mount or rafter mount style where they attach directly to the deck, attaching to the rafters, trusses, purlins, or other types of roof structure. Jumping into those snow brackets specifically, they are designed to penetrate about 3 inches into that blanket of snow on the roof and freeze in place. So that snow freezes to those brackets and it holds it in one large glacial mass. So the most important thing about the brackets is they are not designed to stop the snow once it's already moving. They're designed to stop snow from ever moving. They are not designed to stop moving snow. I know that sounds confusing, but they are not made to just be one course along the eave and have the snow slide into them and chop it up like little chainsaws. That is not the goal. The goal of the snow brackets is to hold that snow in place and never allow it to move. So these are placed in an even pattern, staggered across your roof surface, and the goal is to stop that snow from ever moving. They do allow for the proper drainage to occur underneath that snowpack, and snow brackets are designed for most roofing products. They are a very strong product, but the reason that they're installed across the roof's entire surface is because you are installing these with a certain type of fastener, and you can only be as strong as that fastener. So oftentimes they do need to have many of them placed across the entirety of the roof in a staggered pattern to hold that as a blanket up on the roof. Where snow fences act a little bit differently. So obviously you can still only be as strong as what you are attaching to. So a standing seam fence, oftentimes you'll need more than one row if you are clamping onto a standing seam panel. But when you get into like your deck mount fences, your rafter mounts, oftentimes you'll only see maybe one row of these. And the reason for that is they are designed for that last little bit of defense between that snow coming off of your roof. And the reason for that is they prevent those roof avalanches. So the snow will slide your roofs down your roof surface some and come into contact with those fences where it then will freeze. And the reason for the multiple rows is just due to the strength of those. So oftentimes more than one row may be necessary, or maybe you utilize brackets with the fence to prevent more than one row. Brackets with fences are usually recommended for areas that are over a 6 and 12 slope, and also over 120-pound snow loads. So those work very, very well together to utilize both of those. If one fence isn't enough, I mentioned multiple rows can be used. I really want to point out this bottom right photo. This is a great example of snow retention working. This is a project we get photos of almost every single year. That's about 7 feet of snow on a 2-bar system. And there are 4 rows of that 2-bar system going up that roof surface. So if you ever question if snow retention works, that is the perfect example of it. Deck mount fences, I mentioned they go into structure. Oftentimes they go in with lag bolts, always making sure to pre-drill those holes prior to putting anything into your rafters or trusses is very important, so you do not split them. Where clamp-on fences clamp directly to the roof seam and they do not puncture through. Snow brackets and fences are made for almost all types of roofs and from various materials, including steel, copper, and aluminum. They powder coat to match most roof colors. I believe we have 50 colors of powder coat, so there's all different things that you can utilize there for colors and also shapes, sizes, all of those things as well. So what information is necessary to engineer these snow retention designs or a snow retention system? So some of the information that you will need for this is going to be, what is the roofing product and how is it secured? How strong are the fasteners that you're utilizing for not just the product that you're installing, but for the roofing product as well? How thick is your sheathing? What is the force of the snow retention or of the snow on the snow retention devices? What is the weight of the entire snow mass from eave to ridge? What is your roof slope? And how strong is that individual snow retention device? So some of this information you can look up or your roofer can look up. I know I was in Colorado one day. I travel often for work, and I was in Colorado and I walked into an engineering firm and I asked, I think, who they utilized for snow retention or if she had any questions. And she said, "Oh, I don't deal with any of you people. I let my roofer engineer my snow retention systems." And I walked away from that really with a lot of thought, because it's concerning in many ways, and not the conversation with her. That wasn't so much it. But as a roofer, the information is not provided to them. So they would be able to look up or find out information for their projects, such as ground snow load, slope of the roof, roofing material, sheathing, rafter, truss spacing. All of that information is completely available to all of us when we're working on these projects. But since there's no codes or standards for snow retention systems, there's some things that cannot be known or Googled or call and ask somebody. And those things are going to be, what is the strength of this individual snow retention device? So if I have one bracket in my hand or one clamp in my hand, how much snow can this one device hold back? What is the pull-out strength of the fasteners that I'm going to install this device with? And if either one of those things fail, if the device fails or if the fasteners fail, what happens? What is the worst case scenario? What is the fail point of the system? And at what point does it fail? So working with a snow retention company that tests their products and systems to have all of that data is crucial. This is just going to be a very basic test of a snow bracket, and they're just going to run those numbers up there. I believe they get up to like 1,300, 1,400 pounds, somewhere in there. And eventually the fasteners do pull out. So that is most likely always going to be the weakest point of a bracket, is going to be the part where they are installed. So understanding the bracket itself can be very, very strong, but you are always going to engineer to the weakest point of the system, which in that case would be your fasteners. So these graphs are just going to show the number of snow brackets needed for two separate projects. The purpose of these graphs is just to tell you, hey, if you have two projects that are side by side, just send in your next roof plan and get a roofing layout for that specific roof, because sometimes things change. Let's say you're building two cabins side by side. They are identical, but maybe one has a little bit more of a budget than the other. So the reason that that comes into play is maybe they decide to go with a thinner sheathing. So the only difference in these projects is the sheathing that's utilized that the fasteners will attach into. So the graph on the left shows 7/16 wafer board. The graph on the right shows 3/4 inch CDX plywood. And these numbers are showing the number of brackets to install per roofing square. So if you used an old layout and decided to just install those brackets as that layout says, you could be installing twice as many brackets as necessary and just charging the customer more than you need to. Or you're installing half of the number of brackets that you actually need to have a successful system up on that roof, and could most definitely see failures. And I will say, failures with these types of systems are not going to be pretty. I mean, you're installing this into your roofing material or into your structure. So you want to make sure that the system is properly engineered for that specific project. In heavy snow areas, this is just an example of what the placement of brackets can look like in that spacing. The bracket placement will change for every single project depending on all of those things that we talked about, like the slope of the roof, the sheathing type, ground snow load, which is going to be very important for all of our calculations, and everything from there. So this is an example of what that snow bracket layout can look like. Your eave course is always doubled from what you go into the field at. And then as we move on, we can see a snow bracket layout here as well. So these systems are just like building anything else. If you build a bridge and you have poor engineering, the bridge can fail. Same thing for snow retention systems. Poor engineering is going to be just not considering all of the variables of the project. It most definitely can fail when that occurs. And then also following that engineered layout, making sure that you do have proper installation is very important. Now, I am very close with most of my competitors, so I don't ever tell you what products to avoid except for plastic brackets. So with plastic brackets, that is something that I call them very beautiful landscape ornaments. I used to take my children to a pediatrician's office in Utah, and every time I would go, there would be plastic snow brackets just in the parking lot and all over their landscape area. So there's a lot of reasons that adhesives can fail on this. There's a lot of reasons the plastic can become brittle, resulting in other failures. I would just personally avoid these on any project that had my name on it. So retention devices themselves, as I mentioned, they can be very, very strong, but if you're not utilizing any type of engineering or proper installation methods, they most definitely can fail. So I like to point these out and kind of explain to you exactly why these systems have failed that we're seeing. The photo on the left, this is a slate roof. These are brackets that were installed just along the eave course of the roof, and this is important just to remember that part where I said the snow brackets are not made to take that sliding snow. They are made to keep that snow from ever sliding. So that snow comes into contact with them. It pulled many of them out and also folded many of them over as well. The middle photo, this is a installation that did not occur into structure. These fences are just installed into sheathing and they do not have any engineering or proper installation that has occurred. And the far right photo, this is one that really points out that upper roof shedding to lower roofs and how that can become an issue. So they decided to only cover the far sides of both of that upper roof, allowing that accumulated and glaciated snow to end up taking over, folding those roofs over or folding those fences over on each side and then coming into contact with that lower row of fence, which also took a portion of it out as well. You can really see in that photo where those forces were pushing and where it took those fences out. So even with the installation of 1/4-inch plate steel snow brackets, this was a do-it-yourself type of situation. This man said, well, I have a metal background. I will just make my own snow brackets. He made them out of 1/4-inch plate steel and installed them on the eave of his roof. Once again, these are not made to just catch that snow as it slides down. And so unfortunately, the weakest link of this system was not his fasteners. So his fasteners were strong enough, but his sheathing was not. So when the force of the impact of that snow came into contact with those brackets, the brackets stayed, the fasteners stayed, and the sheathing was pulled directly out from that roof surface. So this is a very, very messy situation to have to go back and clean up. PVC pipe, once again, should not be utilized on the roof as a snow retention device. And this fence that we're seeing here on the right has been installed with improper fasteners. These are just tiny little screws when it should be going into the roof with a lag bolt or a large Simpson screw. So I really went into some of the partial installation of snow retention, but this is the biggest reason that you will oftentimes see any type of failure of snow retention is the partial installation. And I understand as a homeowner myself, if you tell me I can just cover an area of something and my kids will be safe and my cars will be safe and my windows will be safe and I don't have to pay to put it all over my entire roof, that's a great thing. But unfortunately, that's just not always how it works. And understanding that the weight of that glaciated snow is going to be pushing across that entire roof surface. And when you only have 6 brackets there to hold it up, with all of that force, oftentimes the snow will make its way either through those brackets, over those brackets, or something like that. Just trying to hold the force of that entire snow mass on 6 little pieces of metal. Same thing with fences. This is something that is seen very often. This was a boys' camp in Utah. And I believe for this project, they were really only supposed to install 2 rows of snow retention and decided that they would throw that third one up there to secure it a little bit and not cover the sides. Well, with that, those 4 seams that we see there that are not covered with snow retention were the complete demise of this entire project because now those seams and that weight on those other covered or non-covered seams have caused these seams that do have snow retention to be torn right off of the roof. This is the same scenario. This is a homeowner that decided to cover their gutter here with snow retention. They already had snow retention along the front and said, oh, well, let's just cover our gutter right over here. Purchased it, installed it themselves. And unfortunately, they did see quite a large bit of damage from that. The important thing that I like to note, though, is this is something that we personally dealt with as a manufacturer. They actually had just ordered it directly from us. And we were able to fix this situation. We were able to replace their roofing material and also give them snow retention to go the rest of the way around their house. But it's not always that simple. It's something that if they're not asking the questions as a homeowner, or if the architect or builder is not asking those questions, oftentimes this can end up being a result of a new construction as well, on something that was built very well and just needed more engineering and consideration for the long run. So upper roofs that shed to lower roofs, this is only about a 1.5 foot gap from that upper roof to the lower roof, and it has damaged those concrete tiles. So understanding that if you are utilizing snow retention, you need to utilize it on both that upper roof and the lower roof to protect those as well. I do have a little bit of information about ice damming, and for once I have talked fast enough and not told enough stories, so we actually have a little bit of time for this. But ice dams, we all know what these are pretty much. They are formed in snow climates. It occurs when the snow and ice that's located at the top of the roof, resulting from the heat loss and the sun and all those fun things, begins to trickle down to the bottom of the roof. So as that snow comes down, it causes the water to actually refreeze into ice. Behind that frozen area continues to come down as more water. I have seen these ice dams as deep as knee deep on the backs of roofs. So this is something that is very, very messy. And then oftentimes as that water builds up, you have those sloshes that come out over top. When it sloshes out over top and freezes, that's when you have those icicles that are occurring. Over time, these ice dams can cause water backups, the melting snow and all of that. And with those water backups, that can come into your building, your home, your insulation, backside of your roofing material, all of that, and just end up being a complete leak problem before you ever even know it. So these are massive examples of ice dams. And then, as we discussed a little bit earlier, Europe does have a little bit of a different strategy, actually complete opposite of what we do in the US and Canada. So they do things a little bit different with roof designs as well to help eliminate ice dams. So as I mentioned earlier, they do use a low slope roof in mountainous regions. This does help to hold the snow on the roof. And I do want to say that this example is still not the perfect example for every situation. Just because the Europeans do it doesn't mean that it's something that we have to do or that it's the correct way to do it. It's just information that we like to provide to you. But with that, they equalize the roof's temperature to the outside ambient temperature with a ventilated roofing system. So what they're doing there is moving a large volume of air from eave to ridge, an equal amount of large volume of air as well, and incorporate more insulation with a greater R value, so a minimum of R50. So depending on your location, that might be an unheard of amount of insulation. If you're in a mountainous region, oftentimes that's pretty much code. So they also would then hold the snow on the roof with a snow retention system, creating that insulating blanket. So these are just two different photos to show the difference of your traditional roof system on the left, where you have those varying temperatures, that ice damming that can occur, the air that's coming through, and then that photo of that cold roof system on the right-hand side, where you have an equal amount of large volume of air moving through there, creating the backside of the roofing material and the inside of your attic to be the same temperature as the outside ambient temperature. Oftentimes, codes and standards for cold roof systems will actually only account for about 1/4 of the amount of air that's necessary to actually make that attic match the outside ambient temperature. So if you can't match up those temperatures exactly with that amount of airflow, then you do not have a cold roof system. Another advantage to the cold roof system is condensation that occurs when the dew point is reached. The ventilated roofing system does provide a means for that water vapor to escape before it condenses in the attic or the backside of the roofing material. But cold roof systems can be very, very difficult to design since all slopes do need to vent equally from eave to ridge. So some other options that can be utilized in that manner can be a super insulated roof or a hot roof. it can be a good second option, but sometimes the effectiveness of these are reduced in higher elevations due to the thinner air. They also can have issues with condensation due to the entire roof system not being fully insulated or sealed. So an example of that would be spray foam. If you're spraying foam between the rafters and trusses, but not covering that entire rafter or truss, it can allow moisture to absorb into the wood, and that moisture can transfer all the way through that wood into the sheathing and rot the roof out before you ever even know you have a problem. Any additional heat sources that cause moisture can also reduce their effectiveness, such as ductwork, furnacing systems, sprinkling systems, canned lights, all of those good things. So these are just two examples. One is a traditional roof. It's not vented, has massive ice damming issues. And the other photo on the right is a vented cold roof system that does have snow retention on it. These are only about 100 yards apart in Sun Peaks, Canada. The one on the right was built with the one on the left in mind completely, and had brought a lot of people involved into this project to make sure that it did maintain the integrity of the roof and of the surrounding areas. So with that, that does conclude the AIA portion of my course. I do want to just kind of let you know that we offer free engineering for any project you may have. You just send that over to us and we're able to get that back to you, usually within 2 to 3 business days, depending on what's going on with us. We have guide specifications for all products, which is available to you through Acelab. Data sheets as well, and we have a system warranty. It's a lifetime warranty. We're a small company, family owned. If you have a problem with our products, you're calling and speaking to the CFO of the company, not a call system way out somewhere, or you're calling me and saying, "Hey, Mindy, I have a question for you," and then we're able to go from there. So Kayla, if you are ready, you can go ahead and take over. I appreciate everyone today, and I hope that you learned something.
Thank you. Yeah, that was amazing. All right, let's jump into some questions. All right, um, so far, I have just a couple questions coming in. So, folks, if you have any additional ones, now's a good time to drop those in there. So I have somebody who's asking for a copy of the presentation. Mindy, are you able to share those with
Yes.
folks if they're interested? Okay,
Yeah, I usually
perfect.
do
Thank
have
you
to
for
send
that.
it like through a Dropbox link or something to that type because it is so massive. But I can usually share a link or something like that to it.
That's great. Yeah. And Mindy, if people are interested in having like a similar presentation to this for their office or something, is that something you guys are able to do as well?
Absolutely. So I am the only one that does do presentations. So in-person ones, we just have to work around my schedule a little bit, because I do manage the US and Canada for us. So that's a lot of in-person presentations that I usually do. Webinars are very, very easy to pop in, and anything else I can just schedule around. So absolutely, I can come directly to you. I can do lunch and learns, those types of things. And I also provide like hands-on demonstrations as well. So some architects have joined together with local contractors and had me come in and kind of do like a dual presentation where I'm training with the architects and also training with their roofers that they normally work with as well. So
That's awesome. That's a great idea. Yeah. Well, folks, if you're interested in something like that, feel free to uh, put a note or something in the post-webinar survey, or feel free to drop it in the Q&A now, whatever is best for you. But awesome. So next question I have is, how do you ensure the system won't create ice damming issues?
So ice damming, as I mentioned, is more caused by the difference of heat and cold on the roof surface or behind the roof surface. But the snow retention devices themselves do allow for a gap from that roof surface to the snow retention device. So that does help tremendously in preventing that ice dam because it actually clears the everything underneath it and keeps everything off of that roof's deck and keeps it onto that snow retention device instead. So since the snow is frozen to the device rather than the roof surface, it helps provide that means for the water to escape off of the roof and drain properly.
Perfect. That's great. And I think we have time for one more. All right. So what warranty coverage do you provide on materials and performance?
So as long as the installation follows our recommended install for that project, then we cover all of the materials if anything happens to it. But honestly, it's always going to be a case by case situation. And I feel that our company has always been way more than fair when it comes to these situations. I've worked for companies who, if you walked away, they would say, "Oh, that's your problem," and that's never worked for me. So that's something about TRA that has always been great is they are like, okay, this is their product, this is their passion. And so they don't want to walk away with you having an issue with their product one way or another. So we usually find a way to solve that. It's not always going to be the small print situations like you deal with big manufacturers. It's going to be more of a personal level for sure.
So that's perfect. I think that answers our questions then. All right. Well, we are right at time. So Mindy, would you like to wrap us up with any final notes or comments?
I just appreciate everyone's time today. I hope that my internet was not lagging. It is on my end. I'm noticing that my face is not lining up with what I'm saying, so I hope there was no issues that way. And I just appreciate your time. I hope if you have any questions or issues that you contact me. I'm more than happy to follow up on that.
Yeah, I think the audio has been clear on my end, at least. I think it's maybe just the video that's lagging or something, but yeah, all good. Thank you so much for that presentation. And yes, thank you everyone for joining us today. Again, if you filled out that poll, keep an eye on your inbox. We can go ahead and connect you with Mindy today. So let us know if you have any additional questions, and we appreciate any feedback as